Hello, everyone. I'm Ariel Ekblaw. I am the director and founder of the MIT Space Exploration Initiative, and also a very proud Yale grad from the class of 2014. I'm so pleased to be here today to speak to all of you participating in and listening to the 150th anniversary of the Celebration for Women at Yale. Thank you for having me. What I'll be sharing today is how we work in principles of egalitarianism in our work to democratize access to space exploration. We really are at the cusp of interplanetary civilization in this decade and the next, making more progress towards lunar settlement and moving out to Mars. And here I'll tell you a little bit about the work that's led up to this, what's happening in the space industry to make this moment possible, and then particularly our efforts at MIT to prototype the artifacts of our sci-fi space future. If you'd like to get in touch with us, here's a little bit of information on the title slide. And now for an understanding of where we're at in the industry. Most of you will be familiar with the International Space Station, right? This has been in orbit for many years. In fact, people born after the year 2000 have never been alive during a time when we didn't have a space station continuously inhabited in orbit. And yet we're seeing now the beginnings of new commercial space stations being planned. So the International Space Station was this international collaboration between many different countries led by NASA. And now we're seeing Axiom Space Station or Bigelow getting involved, or NanoRacks beginning to position themselves to service commercial interests, maybe space tourism, certainly science in orbit, and stepping stones towards lunar and Mars exploration here in what we like to call the near-Earth cocoon outside of Earth, right? So low Earth orbit, just in our immediate vicinity. In addition to activity in LEO, or low Earth orbit, NASA has decided we are returning to the moon, and this time for the first woman who will land and put boots on the moon. This is the Artemis program led under the current NASA administration, and we at MIT are engaged and active in preparing prototypes for prospective lunar payloads. And then finally, thinking out beyond to Mars, some of you may be familiar with Elon Musk and SpaceX and his visionary work trying to get humanity to be an interplanetary civilization. And this is a rendering, courtesy of SpaceX, of some of those plans that are coming to place. So I show this to make evident to the group that we're closer to this future than you may think, and we really have made immeasurable progress since the close of the Apollo era and the close of the shuttle era in returning to an active future for space exploration, and it's on our doorstep. At MIT, we are designing, building, prototyping, making real our sci-fi space future. So if you look at this image, this is an artist's render. It actually shows 14 different artifacts, different experiments and products, everything from entertainment. How do we ensure happy mental health and stable mental health for future astronauts or deep duration, long duration space missions, but also agriculture, thinking about the future of space food and space food growing closed loop systems in resource constrained environments. There's a principle here that we really try to build upon, which is, can our work also come back down to benefit life on Earth? So our work in space has these analogs and this ability to, in a much broader way, benefit Earth citizens. And we think about this through many of our payloads, but in particular, agriculture for extreme environments. You can also see many other examples, from playful, how do you move through zero gravity spaces like a Spider-Woman type artifact, to the actual space architecture that you're within. And we think about artifacts at all of these different scales. Our mission is to democratize access to space exploration. We do this by inviting new disciplines into the creative practice. So while I was trained as a physicist at Yale in particle physics, I found my way into aerospace and really value the breadth of expertise and the humanities that we find at Yale. And so my team includes artists and designers and philosophers and ethicists, in addition to the engineers and scientists. And this is the magic of democratizing access to who gets to be part of creating and building and envisioning that future. We also aim to revolutionize life in space. So while other groups might work on propulsion for rockets or kind of next step iterative technologies for our space exploration future, the freedom that we are given at the MIT Media Lab allows us to imagine provocative, next generation, risky prototypes that might not be funded elsewhere. And this is the mission where we say we're working on the sci-fi aspects of our future, trying to really make these real with MIT technology. And then finally, to realize space exploration. So I always say you're not a real space program if you're not actively launching into space. And so we're not a design house. We actively build these prototypes and this research, and we test them through many different space simulation and real space environments to make sure that we're contributing practical technology and experiences to the future of life in space. Our long-term North Star goal is to create Starfleet Academy. If any of you out there are science fiction fans or know a little bit about Star Trek, this will be familiar to you. This is where the space cadets would go to learn to become the Captain Jean-Luc Picards or the captains and space doctors, space psychologists. But it was also where the technology of the USS Enterprise was built. And so we have this amazing moment in the space industry and this special lab at MIT, informed by values of egalitarianism, to really bring together what could be a future like Starfleet Academy. This is the team, so you can get to know us just here briefly. So it's now grown since 2016, when I founded the initiative, to a group of over 50 graduate students, staff, and faculty. We're very fortunate to have some incredible mentors on our team, including David Newman, the former Deputy Administrator of NASA under the Obama administration. And we now have a very active staff team in addition to all of this ecosystem of graduate student researchers that are working with us. Our overall ecosystem begins with this core group, the 50+ graduate students, staff, and faculty, but very quickly expands into the member companies of the MIT Media Lab that we work with that bring innovative constraints and future business models and other ways of thinking about life in space. Collaborations across MIT with the MIT Aero Astro Department, Earth and Planetary Science, and others. And then also now very close relationships with several space agencies around the world, including NASA, ESA, the European Space Agency, and JAXA, the Japanese Space Agency, and a host and bevy of different new space age startups. It is really this ecosystem that enables us to do all of the 40+ in-house research projects that we take on. And this is what you need. You know, he says, takes a village to form a community, in the same way it really does for the creation of a robust future for life in space. This is a photo of Annie Liu, an artist who we took on our very first microgravity flight in 2017. This is a plane-based experience of weightlessness. So you're in a plane like what you would take to cross the Atlantic, but it does what you want a plane never to do. It pitches really steeply upward and really steeply downward at 45-degree angles and establishes this parabolic arc, and you get 15 to 20 beautiful seconds of weightlessness, of microgravity at the top of those arcs. And then you do that 30 to 40 times. So it's like a roller coaster in the sky. And this is Miss Annie Liu on our very first microgravity flight. This flight is the very first in a series of, and a cadence of annual launch opportunities that we take the community through. So we start with this zero-G flight. If you progress from there, we're able to try to use space on a Blue Origin suborbital rocket. So this gives your experiment or your hardware 3 minutes of time in microgravity to do the operations you might need to do autonomously, because you don't get to travel along with it yet. And then if all goes well, the rocket returns. And then moving up to the International Space Station, we recently completed a 30-day mission on the International Space Station in March of 2020. And now our sights are set on a return lunar payload mission with Blue Origin targeting 2024. I'll now just show you briefly some research highlights and what the endeavors of all of these different graduate students are spent on a day-to-day basis. So we work on everything from additive manufacturing, the future of zero-gravity 3D printing, to space fashion and aerospace grade textiles and technical development for the future of space suits, soft robotics, self-assembly, which is my passion. So I did my PhD in self-assembling space architecture. So can you have habitats around the Earth, Moon, and Mars that come together like Legos on their own? They snap together and form these mega structures for future space tourist habitats or habitats for astronauts and others. And then, of course, we also dive into the arts, so thinking about everything from music and musical instruments that can only be played in microgravity, so they don't make the same quality of sound on the Earth when you're trying to play them, to the future of space food. Food for extreme environments, as I mentioned earlier, is a core focus area for the Space Initiative, and we're thinking about holistic health and wellness and well-being for the future people, Earth citizens, that we may be sending into space. I'll just highlight one project briefly here on our policy portfolio side. We are working with Open Lunar Foundation out in San Francisco to bring about a collaborative, coalesced, and efficient future for lunar stakeholder activity. So you may know lots of the resources on the moon that different countries are interested in, they're concentrated in some of the same small locations, and we really want to prevent conflict. And so we need coordination among government, industry, academic stakeholders who are planning future missions to the moon to ensure that information is shared, that we can achieve interoperability, and that we can maintain a peaceful future for the surface of the moon. And so if you're interested in learning more about some of our policy endeavors, this is a quick highlight of our Lunar Open Architecture project that aims at achieving these goals. And I'll just close by saying, come to us. We would love to invite you to become part of this community, to get involved and get engaged. And every year we host a flagship event at MIT. It's beyond the cradle, beyond our cradle, the cradle of humanity. And we bring 60 leading space visionaries, everyone from J.J. Abrams and Neil Stephenson, so sci-fi authors and directors, to NASA astronauts, to the CEOs of major space companies. We bring these people together to co-design a richly envisioned future for life in space, for space exploration. And with that, I hope to hear from you. And thank you again so much for having me. It's been an absolute pleasure to be part of the 150th anniversary of the celebration for women at Yale. Thank you.